Hello class, this is Mr. Beckstrom again. Welcome to chapter 3, section 3. We're talking about triangles, regular hexagons, and irregular polygons. And we'll be looking at some area formulas for these. There are quite a few formulas in this section, so it'd be a good idea to use the book to look those up and to make some notes and to try some of those problems. I'll be doing 4 of the problems here today. Alright. So let's start with the Pythagorean theorem. It's one of the most famous theorems out there. You've probably heard of this before. We have the formula c squared is equal to a squared plus b squared. You may have also heard of it as a squared plus b squared is equal to c squared. This is how we solve the lengths of sides of right triangles. So in order to use this formula, the triangle has to be a right triangle. That means it has to have a 90-degree angle. If it does have a 90-degree angle and we're given 2 of the lengths of the sides, we can find the third one. And A and B are going to be the legs. Now the legs of the right triangle are going to be the sides that are adjacent or touching your right angle. The hypotenuse is going to be the side, the longest side, which is not touching your right angle. So when we're talking about A and B, you can assign either side you want to A or B, but C always needs to be your hypotenuse. So let's find the length of A. In this case, I designated this side as A. That would mean that this side would be B, the 9, and 12 would be our hypotenuse. So let's plug it in the formula. So we have c squared is equal to a squared plus b squared. This line right here just means that the next equation is also true then. So 12 squared, replacing the 12 for c and the 9 for b, we get 12 squared is equal to a squared plus b squared. And then we can, what do we do here? We move the 9 squared over to the other side and we solve for a squared. So a squared is equal to 144 minus 81. That leaves us with a squared equaling 63. And then we can take the square root of both sides. Remember, we don't need to do a plus or a minus for this part when we take the square root because we're talking about lengths, and lengths are always positive values. So when we take the square root, we're just looking for the positive value of that value. So a is equal to the square root of 63, and that reduces down to 3 square roots of 7, or approximately 7.9. Let's look at an example where we're going to find the hypotenuse of the triangle. So notice that the right angle is over here, and this is the side that we're trying to find, which is not touching the right angle. So that's going to be our hypotenuse. So we're going to let that question mark equal C there. We use the formula. We put in 9 and 40 for A and B. Once again, it doesn't matter which one we put in for A or which one we put in for B because they're both sides or legs. And we solve that. We get c squared is equal to 1,681. Putting that in our calculator, taking the square root and the positive value, we get 41. That means that the length of the hypotenuse is 41. Now a quick note here, the length of our hypotenuse should always come out to be greater than either of our sides. So if we get an answer that's less than one of our sides, we know we made a mistake somewhere. And vice versa, if we find the area of a leg, it should always be less than that of our hypotenuse. So if we get a leg that's larger than our hypotenuse, then we also know we made a mistake somewhere. Alright, so the area of a triangle. So it's going to be the area is equal to 1/2 base times height, where b is the base and h is the height. Now very important, so important that I put it in red there. Don't forget that the height is perpendicular to the base. So when we choose one of those sides of a triangle to be our base, we need to make sure that the height is perpendicular to it. So we don't want to use 2 sides if it's not a right triangle because we're not going to have a 90-degree height to our base. So let's take a look at this next triangle. This triangle, we have the length of all 3 sides, and we also have a a value that meets this side at a right angle, and that length is 5. Now we could use any of our sides for the base, but we want to use the side that has a right angle length to it. So we can't use the 6 or the 12, but we can use the 14. So we use the 14 as our base, and then that 5, since it meets the 14 at a right angle, we can use that as our height. And then we're just going to plug it in the formula, 1/2 base times height, or 1/2 14 times 5, and you should get 35. Alright, let's look at our last example that we're going to do on our slides. We'll look at the area of a regular hexagon. Now notice that in the book they give us two formulas. They give us the 3a squared square root of 3 over 2, which this is going to give you the exact area of a hexagon, or you can use the approximation. This is a formula that we use in real world applications, like if we were actually doing woodwork or some type of metal work. We would probably use this approximation because, well, it's going to be just as accurate as the exact answer up until about, the 1,000th or 10,000th digit. So let's find the area of the hexagon, and let's both do an exact answer and an approximation. So we notice that the A is a side. We have a side of length 10. So to do the exact solution, we just plug it in that first formula, and you should get 300 square roots of 3 over 2. If you put that in your calculator, you're going to get around 259.8. And then the approximate solution. So this is if we're doing a real-world application, like I said, like woodworking. We put the side in there, and you can see that we're going to get 259.8 centimeters. So it's going to be just about as accurate as our original solution, and for most purposes, that's going to be fine to use as well, that formula. All right, thank you all. Have a great rest of your day.